Sadar Pranam. Today's talk, which is on Indian planetary systems missions, is very important for our country, ISRO's achievements. Today's talk is basically dedicated to the planetary exploration program in India that started with the Chandrayaan-1 orbiter mission to the moon in 2008. This was followed by a mission to Mars, the Mars orbiter mission, popularly called MOM, launched in November 2013 and arrival on Mars in September 2014. The second India mission to moon is the ongoing Chandrayaan-2 mission. India also has a planned mission to study Sun from the L1 vantage point called the Aditya L1, as well as future planetary missions. This talk will briefly discuss the Indian planetary missions, related challenges, and highlight the science derived from them. Today, I have Dr. Sunita Farakia, the head of the Department of Education in Science and Mathematics, NCERT, with me. I request Dr. Farakia to welcome Dr. Anil Bhardwaj and to introduce him to the viewers. Dr.
Thank you, Dr. Gagan. I am extremely fortunate and it's my great pleasure to introduce Professor Anil Bhardwaj, who is Director of Physical Research Laboratory in Ahmedabad. After PhD from the Indian Institute of Technology, Banaras Hindu University, he joined Indian Space Research Organization in 1993 at the Space Physical Laboratory of Vikram Sarabhai Space Center in Trivandrum and was subsequently the director of SPL VSSC, Space Physics Laboratory of Vikram Sarabhai Space Center during 2014 to 2017. He initiated the research in planetary sciences at SPL and contributed to the planning of planetary mission of India in ISRO. He was the principal investigator of SARA experiments on the first Indian lunar mission Chandrayaan-1. He is principal investigator of Menka experiments on the Indian Mars orbiter mission. His team have PI-led experiments on Chandrayaan-2 and Chandrayaan-3 lunar missions, as well as on Aditya L1 mission. His primary research field is planetary and space sciences, including solar system, X-ray astronomy, and theoretical modeling of emission and phytochemistry in planetary upper atmospheres and ionospheres and comets, and solar systems exploration. He has used space-based Chandra and X-ray multi-mirror Newton and Hubble and ground-based telescopes that includes Indian Giant Meter Wave Radio Telescope. He has published more than 160 peer-reviewed research papers in international journals, several book chapters including a chapter in Encyclopedia of Solar System, and has supervised many students. Professor Bhardwaj has received several awards and honors, including the two most coveted science awards in India. One is Shanti Swarup Bhatnagar Prize in 2007 and Infosys Prize in 2016. He is an elected fellow of all the three science academies of India, the recipient of Distinguished Alumnus Award of ITBHU in 2015, INSA Venu Bapu Memorial International Award 2016, and Decennial Award of Indian Geophysical Union 2017. ISRO honored him with their highest award, Outstanding Achievement Award in 2017. He is an elected academician of International Academy of Astronautics 2018, member of International Astronomical Union, and is currently the J.C. Bose National Fellow. So, there is a long list. Now I think that we are extremely, viewers, we are extremely fortunate to have Professor Anil Bhardwaj with us. Now I request Professor Bhardwaj to take over. Thank you so much.
So, viewers, we are going to have a highly decorated scientist of our country today with us. So, Dr. Bhardwaj, it's all yours, please.
Thank you, Dr. Sunita, Dr. Gagan, and Namaskar, Suprabhat. Very good morning to all the students and all the viewers and listeners. It's a privilege for me to talk to you today morning under the program of NCERT, Listening to Learn. And today I'm going to talk to you about Indian planetary missions, भारतीय जो planetary missions हैं उनके बारे में. And before talking into that and taking you to the journey to different planetary missions, I would like to introduce to you the PRL, the Physical Research Laboratory, one of the oldest institute in India, which started the space program in India, and that is why we call PRL, or Physical Research Laboratory, as the cradle of space science in India. And this all started in the year 1947, which is also the year of independence. And as India is celebrating 75 years of its independence, PRL, or Physical Research Laboratory, is also celebrating its platinum jubilee. So it all started with Dr. Vikram Sarabhai, who established the PRL in the year 1947. And about 2 years back, we had the birth centenary of Dr. Vikram Sarabhai. To celebrate the platinum jubilee of PRL, we have started the PRL Ka Amrit Vyakhyan, which is a 75 episode series of Vyakhyans or colloquiums happening every Wednesday at 4 p.m. So you can log in into PRL YouTube channel to listen live the talks delivered by eminent scientists, technocrats, engineers, as well as people from arts, science and literature. Today's talk is on space missions, and as I just mentioned that Indian space program started with the establishment of PRL in the year 1947. It is the dream of Dr. Sarabhai to start the space program in India. He is called as the father of Indian space.
NCERT में talk है ये.
And
my team, please.
Which all started in the year 1947, and it is actually the 11th of November. If you look at how this establishment came into existence, the foundation of PRL was laid in year 1952 by none other than Sir C.V. Raman, the Nobel laureate of India, because Dr. Sarabhai treated Dr. Raman as his real guru. And this building of PRL, which is now more than 60 years old, is inaugurated in the year 1954 by Prime Minister of India then, Pandit Jawaharlal. And you can see the building of PRL when it is celebrating its 75 years in the bottom right. PRL also has another campus in Ahmedabad, which we call as Thaltej campus. This is the second campus of PRL, which came into existence in 1980. And PRL has two offshore campuses. One is in Udaipur, in the middle of the Fateh Sagar Lake, which we call as Udaipur Solar Observatory, which is the most important observatories to study the sun, and it is situated in the middle of the lake. And then we have a telescopic observatory in Mount Abu, which is used for studies in the visible and infrared. And they all came into existence in the year of 80s. So this is about PRL, different campuses. But if you look at the logo of PRL, which you see here on the screen, and on the right side you see a circle with a cross, which is the symbol for the Earth. And on the left side you see a circle with a dot in the center, which is a symbol of the Sun. And both these circles are encircled with a bigger circle. And if you translate this meaning of logo of PRL, it means PRL research encompasses the Earth, the Sun, immersed in the fields and radiations reaching from and to infinity, all that man's curiosity and intellect can reveal. So this is how the whole research of PRL is, that it encompasses all the studies from the infinity to infinity. And this, if you translate into various research fields of PRL, it includes astronomy, astrophysics, solar physics, space atmosphere science, atomic molecular physics, theoretical physics, geosciences, and planetary science. So essentially what we are doing here in PRL is pursuing internationally competitive research in all the domains of sciences. And if you look at how the things evolved in PRL over the years, starting from the establishment in the year 1947, when cosmic rays and atmospheric science was the core area of research, radio physics and theoretical physics was added, and that was a time when ISRO and INCOSPAR was established in the year 1969. We added earth and planetary sciences, infrared astronomy and plasma physics, and in 70s we also had the formation of Department of Space, which all is an offshoot of physical research laboratory. In 80s we have particle physics and solar physics added, and IPR, which is Institute of Plasma Research, came out of physical research laboratory to become an independent institute, and now it is under Department of Atomic Energy. In 1990s we have laser physics, quantum physics or optics, astroparticle physics, cosmology, nonlinear dynamics, and composition physics added. And in the year 20 or the new millennium, you can say, we added solar astronomy and planetary exploration, and in 2010 we added low temperature astrochemistry. So this is how the whole studies in PRL got evolved, and PRL has actually contributed to national building in a big way. I hope you can recognize some of the faces which I'm showing over here. Of course, everybody knows about Dr. Abdul Kalam, the President of India, who was with ISRO, but he was actually working in physical research laboratory before moving to Thumba in Trivandrum. Professor U.R. Rao, the chairman of ISRO and Secretary Department of Space, and Dr. Kasturi Rangan, whom you must be well aware, who has now formed the new education policy of Government of India. They are all alumni of PRL. We are all seeing many other faces whose names are written there, and probably this could be an exercise for all of you to find out what they have all done. Okay. Now coming to the main topic of today's talk, that is Indian planetary missions. Indian planetary missions includes exploration of Moon and Mars, and I will also talk to you about how we are taking up new challenges to go to unexplored planets like Venus or missions to asteroid and comets. If you look at the space science activities in India, it all started with PRL, developing space payload, but the first launch of the rocket happened in the year 1963. It was precisely in the November of 1963 that we had the first rocket launch from Thumba, which is deep down south of India in Trivandrum. And the experiments or the payloads which was flown on the first rocket flight was developed in physical research laboratory. Subsequently, India undertook the making of the satellites, and we had the first rocket, first satellite, Aryabhatta, launched in the year 1975, and the project director of this first Aryabhatta was Professor U.R. Rao, which I just showed you in the picture. Subsequently, we had many other missions like SROS-C, C2, Indian X-ray astronomy experiment, SOX, coming up in 80s and 2000. And they were all concerned with looking at X-ray astronomy and atmospheric sciences, but all from orbit around Earth. We had the first planetary mission of India called Chandrayaan-1 mission, which was launched on 22nd of October of the year 2008. And we reached Moon after 16 days on 8th of November 2008. This mission, which we call as Chandrayaan, Chandra and Yaan, mean Moon spacecraft. It has 11 experiments on board. It was truly international in character because there were 10 other countries other than India participating in this mission. And we have 3 experiments which are going for the first time for remote probing of a planetary. If you look at the picture on the right, you will see the various experiments name in short, whose expanded names are given in the down. I will not go into detail of this. This is an exercise again for all the students who are listening today to find out what is the full form of each of these experiments, because this is one of the most celebrated experiments or mission of India, not only India, of the world, because it not only discovered water on the moon, it also found the distribution of water. The first and foremost is the Chandrayaan discovered water on the moon. Till that time, we are all thinking the moon is bone dry, there is no water on the moon. But Chandrayaan-1 mission told no, water exists on the moon and it is there in ample amount. It is more in the polar regions compared to the equatorial regions, but it is well distributed. There are many other results which has come out from the Chandrayaan-1 mission, including, of course, not only water on the surface, but also in the subsurface of the moon, particularly in the polar regions, which we call as permanently shadowed regions, which never see the sunlight, and even in the exosphere of the moon. Because moon doesn't have an atmosphere, it is a very, very tenuous atmosphere, which we call as exosphere. The densities of such atmosphere is almost like 10 to about 10 to 10 to 15 orders of magnitude lower than what we see on the Earth. It has also seen large expanses of crystalline fieldworks, which in turn validate the lunar magma hypothesis, or essentially how the moon came into existence. We discovered mini magnetosphere on the moon, the smallest magnetosphere in the whole solar system. And we have found out many other features about craters, volcanic vents, and lava tubes, talking about that the moon is geologically active, has been active in the very recent past in geological time scales of 10 million years to 100 million years. Many results which are summarized in more than 180 scientific publications. Some of them made the cover pages of the journals, international journals like Science or Geophysical Letters. And one of the pictures which I like very much is how the Earth looks from the moon. This is the image taken by the Chandrayaan-1 terrain mapping camera on 22nd July of year 2009. And this is how the Earth looks like, taken from an orbiter around the moon. And you can see the Earth is full of large amount of clouds because it is July here, the monsoon period. Okay. And why we did that? Because we are interested to actually look at the shadow of the moon on the Earth, because it was an eclipse day. And we wanted to track that shadow. But unfortunately, because of the clouds, we could not get the clear images. How the moon looks like? I would like to play this movie and see if it works out fine. If it is not working out, I will skip. I think it is not working out well. So, my God. I think there is some issue with respect to playing this movie. So, I think I will close down this and restart because there is an issue with respect to playing this movie. Close the program. So, just be there for a moment. Don't worry. I will skip this because it's not playing this movie on this platform.
I believe, Dr. Anil, it is on YouTube as well. Can you just give the keyword so that our viewers can see it later on?
I will do that in the end.
Okay, all right.
Okay, so I hope you can see it now.
Yes, yes.
Share
it's
slides.
visible.
Okay.
Yes.
So I will quickly move to the Mars orbiter mission, which we call as MOM, Indian Mom to Mars. So Indian Mom, India ki mummiyan Mars pe ja chuki hain. Okay, that's what it translates to. And this is also a well celebrated mission because it made India the first country in the world to have a successful insertion of an orbiter around the Mars in the first attempt. No other country in the world has done it. Okay. Not only this, this mission, which we launched on 5th of November of the year 2013 and reached Mars on September 24 of the year 2014, after 10 months of journey, is still working around Mars. It has a lifetime of 6 months, which we planned, but it is still working after more than 7 years in orbit. And if you look at Mars, which is available now in the sky in the night, you can imagine that the Mangalyaan or Mars orbiter mission is going around that planet. This instrument or this mission actually has 5 scientific experiments or payloads we call, and it has undertaken the journey for 10 months, but not only that, it is in orbit around the Mars now for more than 7 years. It departed from the Earth on 1st of December 2013, arrived around Mars on 24th of September 2014. Okay. If you look at the experiments which is there on this mission, we have 5 experiments on board. Total weight is about 13 kg, 13 kg. But the total spacecraft mass is 1300 kg or 1.3 ton. Okay, so the whole mass of the payload is about 1% of the total mass of the spacecraft. There are 5 experiments. One of them is MANCA, which stands for Mars Exospheric Neutral Composition Analyzer. And this is an instrument where, when I was at Vikram Sarabhai Space Center at Space Research Laboratory, we developed this instrument, and this is also providing excellent data science about the distribution of gases in the atmosphere or exosphere of Mars. We also have Mars color camera, methane sensor for Mars, thermal infrared imaging spectrometer, and laminar. And they are all working very well. Now, if you look at the whole spacecraft, you will see these all different instruments mounted at different locations on the spacecraft. What it means is that depending upon the science objective of each experiment, they are mounted at different locations. This is a full disk image of the Mars taken by the Mars color camera. And if you look at this, you will see the top side is the North Pole, the bottom side is the South Pole. And if you look in this picture, which is taken at a different time, you will see a lot of freezing happening on the poles. This is a time when the Mars is farthest away from the Sun. Mars actually has a much more elliptical orbit around the Sun compared to Earth. And that is why, if you look at when the Mars is closest to the Sun and when it is farthest, it moves almost like 1/3 of the Sun-Earth distance. 1/3 of the Sun-Earth distance, which in turn means its orbit is highly elliptical. And that is why you see much more changes on the Mars compared to that we would expect on planet Earth. This is the Phobos, which is a small satellite of Mars passing in front of the Mars. You will see a small dot on the top right side of this picture, which is black dot moving. This is the Phobos shadow falling on the Mars taken by the Mangalyaan, the Mars orbiter mission. Okay, and you also see many features on the Mars. One of them is the Valles of Marineris, which is the largest canyon in our solar system. but you are not able to see it because it is full of dust and clouds. So Mars at certain time gets filled with large amount of dust, and that is called, we call it dust devils or dust storms, which sometimes can engulf half of the Mars. And that's why this dust period, which you call as dust devil periods on the Mars, is very exciting and very, very different compared to what we see on the planet Earth. Using MENCA, we for the first time found how the gases in the atmosphere of Mars changes as a function of altitude, and that too in the evening time. And we found that Mars, which is essentially dominated by carbon dioxide, changes to atomic oxygen dominated atmosphere at an altitude of somewhere around 250 to 60 kilometers, which was quite surprising because we were expecting it to happen somewhere around 200 kilometers or 250 kilometers, but it is happening at a much higher altitude than is expected. Not only that, it also provides us information that the things are very different when you look at the Mars in completely sunlit or noontime, evening hours, and night sky. And this all information came from the Mangalyaan or Mars observation. We also discovered suprathermal argon. Now, what is the importance of suprathermal argon? Argon, which has a temperature little higher than the normal or ambient temperature in argon, will help it to escape, particularly from a region called exosphere, where the atoms or molecules don't collide. So if the atoms or molecules don't collide, they will be having easy path to escape from the planet. And that is what in turn translates that there will be larger escape, or the escape rate may be higher on the Mars than what we know now. And this all study has come from the Mangalyaan mission using the MENCA instruments. We also came to know that there are large orographic features on the Mars, and they are playing a dominant role in forming clouds, particularly on the leeward side, that is the anti-wind side. Orography means mountains, for example, play a dominant role on the Mars now, as we know, and they are the one which creates these clouds on the leeward side, which is, that means the side which is on the opposite side of the flow of the wind of the mountains. Here you will see Deimos, which is another satellite of Mars, which is smaller than Phobos, and we were able to see this because of much elliptical orbit of the MOM around the Mars. And this is the first image which has been captured about Deimos, which is a very small satellite of about 20 kilometers or so, and very odd shape, very small and very odd shape. But this is the first time that we have got a full global picture of the satellite Deimos of the Mars. Now, after the launch and arrival at the Mangalyaan on 24th, the Mangalyaan on the Mars on 24th of September 2014, one of my colleagues from US sent me this picture, and he says that the MOM has become so famous that it has come on the Coke diet. After 1 month of the Mangalyaan arrival on Mars, that is October 24, year 2014, the Google celebrated the Mangalyaan with this doodle. And Amul, you know, I hope all the kids may be aware about Amul, right? So Amul came out with this: ISRO's cow Amul, ye cheez badi hai mast Mars. So this is how the country was celebrating the success of the Mangalyaan. And National Geographic magazine came out with the cover page of the pictures taken by the Mars color camera of the Mangalyaan on its cover page. And Government of India, realizing its importance, has brought the Mangalyaan on the back of the 2000 rupees note. I hope all of you must have noticed this. All the children who have not noticed this, please ask your parents to give you a 2000 rupees note as a gift, so that you can preserve this Mangalyaan coming on the back side of the 2000 rupees note. Now let me move to Chandrayaan, which is the second Indian lunar mission, but it is much more complex and complicated than Chandrayaan because it not only have an orbiter, but also had Vikram lander and a rover. Lander supposed to land on the surface, soft landing, and the rover, which is sitting inside the lander, has to come out and perform on the surface of it. We had the launch of the Chandrayaan-2 on 22nd of July of the year 2019, and we arrived around the moon in August, 28th of August, and then we started circularizing the orbit so that we can go into 100-kilometer circular polar orbit. And subsequent to that, the lander was released to land on the lunar surface, very close to the polar regions, and we all know what happened on 7th of September, year 2019. We could not do successful landing. Of course, we were very close to the landing. It just happened about a kilometer away from the surface. But it has provided very, very important information about the whole mission. And that is how this mission of Chandrayaan-2, lander and rover, is now coming up as the Chandrayaan-3 mission of the India. Now, if you look at the important experiments on the Chandrayaan-2 orbiter, which is in orbit around moon, working now very well for last 2 years, and providing us very, very unique data, unique science, I should say. It includes terrain mapping camera, instrument for looking at the solar axis, which is coming and falling on the surface of the moon, looking at the water distribution around the moon, more particularly in the equatorial and polar regions, looking at the elemental composition of the moon, looking at the various features, particularly in the polar regions, not only the surface but the subsurface, looking at the lunar exosphere or the distribution of the gases around in a very tenuous atmosphere, and looking at the plasma around. So various instruments have different science objectives. They are all performing very well and bringing out excellent science. And the Chandrayaan-3 mission, which I just mentioned, is going to have only a lander and rover, where our focus is on that as the lander lands, the rover comes out and move on to the lunar surface. We want to know the elemental composition of the lunar surface, or basically getting a ground truth information about the composition of the moon. And that's why we have two instruments on the rover called LIPS and APXS. One of this instrument is developed in PRL, in Physical Research Laboratory, called APXS, which stands for Alpha Particle X-ray Spectrum. The other instrument called LIPS, or Laser Induced Breakdown Spectroscopy, has been developed in Laboratory for Electro-Optic Systems in Bangalore. Now, talking about the instruments on the lander, we are interested to look at the temperature profile of the first 30 centimeters of the lunar surface. Essentially, we are sending a thermometer, you can say, to measure the temperature of the soil and to look at how the heat transfer takes place from the surface of the moon to down. We are looking at the plasma properties around the surface. Is a using instrument for this. So these are the instruments which is going to fly now in the Chandrayaan-3 mission, which is going to happen very soon next year. Some of the images which has come out from the Chandrayaan-2 mission, particularly the terrain mapping camera, you can see that it has provided excellent information about the surface of the moon, various geological features on the surface of the moon, craters on the moon. Actually, moon is full of craters of varied dimensions. Craters of centimeters to meters to kilometers to hundreds of kilometers to thousands of kilometers. And you can see craters within craters. So the crater of a few hundreds of kilometers, you will see craters of a few tens of kilometers inside that. You can see craters of few meters inside that. So moon is actually full of craters. Okay. And this is an image of Sarabhai crater. Sarabhai, or Dr. Vikram Sarabhai, father of Indian space program, and the one who established the physical science laboratory 75 years back. There is a crater in his name, and this crater is situated on the near side of the Earth, the side which we can see from the Earth. So those students who want to see this crater, it is situated at 24.7 degree north and 21 degree east. That means it is visible from the Earth. It is about 8 kilometer in diameter and about 1.7 kilometer in depth. So it's a big crater, okay? And those who are interested can see this crater. So if you perform well and do exceedingly well in your career, probably one of you could get your craters named on the moon, okay? There are many other craters which have been seen by Chandrayaan-2 mission. One of them is Lindbergh crater, which also now you can see that there are craters of varied dimensions around it. There are craters which is situated on the walls of this crater of varied dimensions and inside that. So that is what I am telling. Crater के अंदर crater, crater के बाहर crater, इधर crater, उधर crater, सब तरफ crater ही crater. Okay. The SAR instrument, which is synthetic aperture radar, which is a dual band SAR, LNS band, it is providing information not of the surface but beneath the surface. Few meters to several meters beneath the surface, what is there on the moon. This instrument is looking at it. And there is an instrument called OHRC, which is a high resolution camera, where you are able to see craters of even sub-meter size. You can see craters of 1 meter or 2 meter or even below that. So we are getting excellent information about the morphology and mineralogy as well as distribution of various boulders and craters. The instrument, which is developed in Physical Science Laboratory called Solar X-ray Monitor, is providing information about the sun, but the X-rays which is falling on the moon. So in an orbit around the moon, we have put a Solar X-ray Monitor developed in PRL, which is providing an excellent amount of information about what is happening on the sun, because sun is directly affecting the moon, of course the earth also. And this is the most sensitive instrument ever flown to study the sun. It provides a spectrum in the energy range of 1 to 15 keV every 1 second, And there is a lot of new science which is coming out, which has been published. I will not go into detail of this, except to tell you that we have discovered micro flares or sub-A class flares happening on the sun at locations which are not supposed to have this kind of flares. And because of this made ISRO story of the week. ISRO did a press release, and it has been covered by various media channels. There is an instrument called CHASE, which is looking at the atmosphere or exosphere of the moon, and we have found for the first time how the argon 40, which is a radioactive, okay, how does that distribution takes place around the surface of the moon, both day and night. And you can see here sunset and sunrise, and how this distribution of the argon changes as a function of day and night. So these are some new information which is coming out from the Chandrayaan-2 mission, which is in orbit around the moon. What next? We are now going to study the sun in more detail using a mission called Aditya L1. Aditya means sun. L1 is a location. I will tell you where it is. So the focus of this mission is to study the sun at different wavelengths: visible, ultraviolet, hard X-rays, soft X-rays, as well as look at the particles which is coming out from the sun all the time using the instruments. So where our emphasis is on to look at the sun in more detail than it has been done so far, because we are interested to study how the corona is so hot of 1 million Kelvin, whereas the surface temperature of the moon is only 6,000 Kelvin. So what makes corona so hot? Understanding the coronal mass ejections, the flares, and how sun is connected to earth, because sun is the source of energy for the earth. If sun is not there, earth, human beings cannot survive. So essentially we need to know much more about the sun and how the sun is connected to earth. Not only this, now we have large amount of assets in the space. And there are many activities which happens on the sun which affects these assets in the space, including humans in the space, our spacecraft in the space. And therefore, we need to understand much better and able to predict the processes which is happening on the sun and to take care of our assets in the space. Now, talking about the L1 point, which I just mentioned, this is the center of the sun, yellow circle which you're seeing, and the blue dot in the circle is the Earth. Now, L1 point is a point on the Sun-Earth line, about 1% of the distance from the Earth on the Sun-Earth. So essentially, it is 99% away from the Sun and 1% away from the Earth. It is at almost like 4 times the Sun, 4 times the Earth-Moon distance. Okay, Earth-Moon distance is about 4 lakh. So it is about 16 lakh kilometers away from the Earth. Okay. Now, the advantage is, as the Earth is going around the Sun, this L1 point also goes around us. It is not going around the Earth. Okay. So one can get uninterrupted 24/7 view of the Sun if you go and sit at L1. So that is the advantage, and that's why it is called as a vantage point. There are, of course, many other Lagrangian points which are seeing over here like L2, L4, L5 or L3. These are the locations where if you put a spacecraft, you can have a stable orbit because of the location of the 3 body issues. Probably those who are science students in 12th grade, they may be able to understand it slightly better, or you can ask your teachers. Now, what next? We are now talking about sending mission to Venus and a second mission to Mars, or you can say MOM2. Venus, the picture which you are seeing over here, is not the picture of the surface of Venus. What you are seeing here is clouds of Venus in this picture. Essentially because you cannot see the surface of Venus. Venus is opaque. It is full of clouds. And the clouds are made of sulfuric acid. So Venus is a very different planet than any other planet in our solar system. It is very similar in size to Earth. It has a composition dominated by carbon dioxide like Mars, but it has a cloud somewhere around 40 to 60 kilometers above the surface of Venus, which engulfs the whole Venus. And that's why you can't see the surface of Venus in this. This image is a false color ultraviolet image showing you the clouds of the Venus. Whereas on the top you are seeing a picture of the Mars where you can see the surface features. Now Venus also is very unique in our solar system because it rotates very slow. It takes 243 Earth day to spin on its axis. 243 Earth day. So it will have like 120 days day, 120 days night. So if somebody goes on the Venus, he or she will be sleeping for 120 days and working for 120 days. So the life on Venus will be very, very different than the planet Earth. Okay. Now there are many other features on the Venus. For example, the surface pressure of the Venus is 90 times, or you can say 100 times of that of the Earth. Earth surface pressure is 1 bar, right? All of you are science students, right? You will be knowing 1 bar or 1000 millibar. Okay. But on the Venus, it is 100 times more. So it is 10,000 bar. Oh, sorry, 10,000 millibar. Or you can say 100 bar. Also, the temperature of the surface of Venus is about 800 Kelvin. 800 Kelvin. Whereas on the surface of Earth is about 300 Kelvin. So it is very, very hostile for anybody to live on the surface of Venus. But if you go up, as I mentioned about the clouds, there the temperature and pressure is very benign. It is almost similar to that at the surface of Earth. And that is why now people are talking about that Venus clouds could be a location for human habitat or even for life to exist. Talking about Mars, we are interested now to have much more deeper exploration of the Mars compared to what we have done with the Mangalyaan mission. We are more interested now to even think about landing on the Mars and looking at Mars in more detail compared to what we have done using the MOM mission or Mangalyaan mission. So these are the two missions which are being talked about. In addition to this, we are also thinking about exploring comets and asteroids when we undertake this kind of missions, because we have to travel for a longer time, and we can do a mission of having a flyby to a comet or an asteroid when we go from Mars to Venus, or Earth to Mars, or Earth to Venus. Now, as I'm mentioning about the planets, let me also tell you that in PRL, we also work on exoplanets and we look at their properties. In fact, we have discovered the first exoplanet from India in the year 2018, about 3 years back, which is called as K2-236b. And this is the planet which is going around its star in about 20 days. Okay, 20 days. And it is 600 light years away from Earth. And this discovery has been made using the instrument called PARAS, which is developed by scientists in PRL, and using a 1.2 meter telescope, which is situated in Mount Abu, which is a part of the field. So this is a sub-Saturn sized exoplanet which have been discovered, and that made, or I should say, this is one of the first exoplanet discovered by Indian scientists using Indian instruments. And that is why our Prime Minister, Narendra Modi ji, congratulated the scientists of PRL by writing this tweet on 3rd of July year 2018, writing, "Immensely proud of our scientists who created history by discovering a sub-Saturn sized planet 600 light years away from the Earth. Congratulations to them. The discovery puts India among select countries." So you can imagine that sitting on the planet Earth also, we can do a lot of things. And currently, we are coming up with another telescope exactly at the site of 1.2 meter. So you can see the new telescope of 2.5 meter coming up at this site, which is going to enhance our capability by a factor of 10. So those students who are listening to my talk, who are in Ahmedabad, who are in Udaipur or in Mount Abu, can visit these facilities of PRL. So you are all most welcome to come to PRL facilities at these locations and visit. With this, I would like to thank you all for listening patiently, and I can take up certain questions. Thank you. Dhanyavad.
Thank you, Dr. Anil. Thank you. Spectacular indeed. I could see, besides a great scientist, I could see a great teacher, a great motivator today. Dr. Anil, congratulations. You started with giving the homework and then motivated children to have craters named after them. Viewers, for your in the same context, it is just an piece of information to all of you that so far 9 minor planets have been named after Indians. Vishwanathan Anand is one among them.
Yes.
Vishwanathan Anand. So, Dr. Anil, yes, spectacular indeed. Once again, you started your mission, the missions of India from satellites, went to the planets and then to the stars even. That's great. Now I have some questions from children, and some other my colleagues are here to. The first is a little more physics oriented, in the sense that the question is that what do you see that how these craters have been created on the surface of moon or say on other planets? Are they did they come into existence at the time of the creation of these heavenly bodies, or did they come because of the collisions between the two heavenly bodies or by asteroids? Please.
Okay, thank you. It's a nice question, and thanks to the student who has asked this. Craters are actually formed by collision. Craters are generally not formed by any other process other than collision. And all the craters, I just showed you many craters on the moon. You can also see craters on the Mars or any other planet or a body which doesn't have an atmosphere. On the moon in particular, because I just mentioned that moon doesn't have an atmosphere like planet Earth. So any small body which comes and falls on the surface of the moon, or any body like moon, for example asteroids or satellites of outer solar system which doesn't have an atmosphere, they will all be cratered. So cratering or creation of crater on any body is a natural process. And in particular, in case of bodies like moon, asteroids, even asteroids of a small dimensions of tens of kilometers, you will see craters. And this would be a good exercise for the students who are listening today, that you find out how many craters does exist on moon, for example, or any smallest body in our solar system which has craters. Okay. Now, why we don't see many craters on the Earth like moon? We do see on Earth, right? There are many craters. Within India, you can see craters. Lonar crater, which is now a lake in Maharashtra, or recently discovered crater in Rajasthan. They are formed because of the collision of a body coming out, into our atmosphere, passing through the atmosphere, surviving and hitting the planet Earth. Because Earth has an atmosphere, it shields, I will tell you, it shields the impact of these craters. And that is why you don't see many craters on the planet. Also, there is a weathering because of the presence of atmosphere, winds, which over geological time scale will fill these craters. But in the case of moon, there is nothing. So any small object of even a centimeter size coming and hitting the moon will create a crater. Okay. So cratering is a natural process.
So yes, you referred about the friction of these bodies to the in the atmosphere of the earth. Sometimes जो हम देखते हैं उल्कापात होता है, रोशनी चमक रही है आसमान में अलग-अलग दिशाओं में, तो I hope and believe that it is because of the similar kind of things happening in the atmosphere.
Yes, yes. ये जो आप बोलते हैं ना कि तारा चमक रहा या चमकता हुआ तारा दिखाई दिया स्काई में,
जी जी,
ओके, शूटिंग स्टार जिसको बोलते हैं, वो सभी जो है ये स्मॉल ऑब्जेक्ट्स हैं जो कि एटमॉस्फेयर में एंटर कर रहे हैं पृथ्वी के, और क्योंकि पृथ्वी का एटमॉस्फेयर इतना डेंस है कि वो बर्न आउट हो जाते हैं, जल जाते हैं, और जलते हुए तारा हमको दिखाई देता है जिसको हम शूटिंग स्टार बोलते हैं। और ये इसीलिए है क्योंकि पृथ्वी के पास अपना एटमॉस्फेयर। I can tell you there is about 20,000 meteors entering Earth every day. Every day.
20,000.
But you don't see falling on the Earth because Earth's atmosphere is shielding us.
That's great. That's the beauty of having atmosphere around us. Now there are some questions.
That is how we are surviving on the planet Earth.
True, true. But the similar question that in all these things keeping together, how do we see that life may exist on other planets or in other solar systems?
Okay, the existence of life. This is a question which is bothering humanity for very long, not only just the scientists alone, even the kids who are listening to this, कि क्या लाइफ कहीं एग्जिस्ट करती है पृथ्वी के अलावा, और उसका उत्तर अभी तक हम लोग खोज रहे हैं। नाउ लाइफ को कैसे डिस्क्राइब करें हम? लाइफ मीन्स ह्यूमंस, और लाइफ मीन्स इवन बैक्टीरियाज, अमीबाज, वायरसेस is also life, or plants. So life has different forms, and life can survive in extreme conditions. On the planet Earth itself, if you see, life survives in extreme heat, in extreme cold, in extreme pressure conditions. So it is very difficult to imagine that planet Earth is the planet in our solar system itself where life will exist. Only thing is that things are very conducive, both atmosphere wise, pressure wise, temperature wise, distance from sun wise, and water, that life is flourishing on planet.
Yes, very true. The basic definition of life, we know the life which depends on H2O, and the wonder molecule we called H2O. But
Yeah.
yes, often people visualize that there may be another kind of life which may be as dependent on some other molecule as we have life
Right.
on water. But in the meantime, there are several questions which are coming from our children. My colleague Dr. Farakia like to ask you the next question, please.
सर आफ्टर हियरिंग योर टॉक आई एम सो टेम्पटेड, मैं सोच रही थी कि काश मैं भी पीआरएल या इसरो में होती,
बच्चा होती
बच्चा होती। तो मेरे व्यूअर्स के लिए मैं आपसे ये पूछना चाहती हूँ सर कि पीआरएल या इसरो ज्वाइन करने के लिए बच्चे क्या पढ़ें और क्या सीखें?
अच्छा, बहुत अच्छा प्रश्न है आपका कि बच्चों को क्या करना चाहिए,
जी
क्या स्टडी करना चाहिए। पहली चीज है इसरो, अगर आप देखें डिपार्टमेंट ऑफ स्पेस या इंडियन स्पेस रिसर्च ऑर्गेनाइजेशन, इसमें हर प्रकार की साइंटिफिक स्टडीज का जरूरत पड़ता है, चाहे आप फिजिसिस्ट हो, चाहे आप केमिस्ट हो, अभी तो बायोलॉजी भी आ गया है बिकॉज ह्यूमन स्पेस प्रोग्राम है, मेडिकल हो, इंजीनियरिंग की भी कोई भी ब्रांच, इलेक्ट्रिकल, मैकेनिकल, इलेक्ट्रॉनिक्स, मेटलर्जी, मटेरियल साइंस, कंप्यूटर, avionics, aerospace, you name anything. All types of people having different specialization is required in ISRO. Okay, so only thing is you should be bright, you should do your studies very well and excel and complete your basic degrees.
Yes.
Basic degrees can be BTech or MTech depending upon up to what level you want to do, or you can do PhD. In PRL, in particular, we take students who have done MSc in physics or in geosciences, because PRL has a vast program, a very excellent program of research in different domains of sciences. And we'd like to have students who have done their masters in either physics or in geosciences, or they have done MTech in any of these areas. And they come here in PRL, we give them fellowship for 5 years and they complete their PhDs. So any student who is in 12th grade can complete their BSc or bachelor's degree, or even they can do BTech and then come to do research. So they are all most welcome.
Your statement, Dr. Bharadwaj, your statement has made me to recall nearly 4 years ago when we were holding a lecture by Bharat Ratna CNR Rao, and one child asked him that, sir, I am in class 10th and I want to become an astronaut, what should I to do? So CNR answered vividly and said that you first thing you should do, that you should forget about becoming an astronaut today. You first complete your basic studies in physics, you have good physics, good chemistry, good mathematics and some biology, and then start thinking about becoming an astronaut. So your statement today has made me to recall that particular session with Bharat Ratna CNR Rao. Yes, sir. So I look forward seeing you at Mount Abu sometime. We have already visited Udaipur Gong facility, solar facility, solar flakes. We have seen the solar flakes therein, and yes, it is really beautiful to be in Udaipur Lake to see the solar observations therein. We look forward meeting you again, Dr. Bharadwaj. मुझे पूरी उम्मीद है कि अगली बार भी हमें थोड़े दिनों के बाद ही हमें बहुत जल्दी फिर से चाहे वो कोक की बोतल हो या किसी और चीज़ की बोतल हो या हमारा अपना अमूल इसरो को फिर से सेलिब्रेट करेंगे, हम सभी लोग मिलकर सेलिब्रेट करेंगे। हो सकता है कि 2000 से बड़ा और नोट आए, उस पर भी इसरो रिलेटेड कुछ फिगर आए। थैंक यू वेरी मच डॉक्टर भारद्वाज फॉर बीइंग अस टुडे। We really enjoyed. We like to meet you sometime at the NCRT studios. Viewers,
thank you very much for NCRT, and let me give a last message to all the kids who are listening today. सभी बच्चों से ये अनुरोध है कि आप अपनी शिक्षा में उत्तीर्ण प्रगति करें, Do well in your studies. If you can do well in your studies, you can achieve your goals. Keep your goals in your heart, but first job is to do well in your studies. Thank you very much. Thank you for listening.
Thank you,
Dhanyavad.
sir. So please stay. Viewers, this was our attempt to give you a exposure to the recent issues related with Indian planetary missions. As I have already